Hello and Assalamualaikum warahmatullahi wabarakatuh to Dr. Ni Ahmad Ridwan. My name is Iman Hakim bin Hussein and I'm from Section 3, Group T for this Finite Element course. So today I would like to present my group project, which is Bicycle and Sales Analysis. Before that, I would like to introduce my group member, which is my name, Iman Hakim bin Hussein, Edmund Vu Kahyung, IHTIFAZUDDIN bin NASHRUDDIN, ILYA NAJWA binti Mat SANIN, and JULIAIKA binti JOHAN. So first, let's move into the introduction, which cover the background study. So for the background study, the bicycle are used in various sectors such as services, transportation, and even sports competition. As the bicycles are widely used, the design has to be good in terms of body strength and flexibility. Such excessive impact and forces towards the bicycle may harm the bicycle body. So to design the bicycle frame, we must take into account the load applied. So the finite element analysis (FEA) is used by the designer to locate the crucial part of the bicycle when the load is applied. So by performing the analysis, the maximum and minimum stress can be known, thus alerting the designer to make some improvement and modification. The modification can made by the designer is such as material selection, thickness adjustment, and joining part of the bicycle element can be used to get some improvement. So in our analysis, the bicycle frame is used as a model to analyze in different situations, mean different force at different location to get the maximum and minimum stress, and also the deflection and the bending stress at a specific location.
As a BMX bicycle is usually used for off-road sports like riding or doing stunts, so the frame need to have the good flexibility and also good strength for the safety of the rider during doing this time. The objective of this case study is to carry out finite element analysis in order to find the total deformation, the stress, and the bending moment at the bicycle frame by using ANSYS FEDL software.
Hello, Assalamualaikum. My name is IHTIFAZUDDIN. So today I will present the methodology of finite element project. So this is the methodology. First, you need to open the workbench software and open the static structure in the toolbox, and then we create a geometry and select a material aluminum alloy in engineering data. The model are created in the ANSYS, and then we create a mesh for the element, and then we select the solution that we want, either total deformation or equivalent stress or bending moment diagram, and then we solve the solution. So next is the analysis and result. So first, when the first case is when applying varied force at the setting position. So in this case, I will add a force 100 Newton from 300 to 700 Newton at the setting position at B, and the C force is the remain same with 100 Newton, and A having a displacement with X is free and Y and Z is 0, while D having a fixed support. So for the result for the total deformation, we produce the highest deformation happens at the top tube nearing the middle tube with a red color. The maximum total deformation happens at 700 Newton. And from the data, we can see that when a higher force is applied on the bicycle frame at the sitting position, it will cause higher deformations. So next is equivalent stress. So this is the result, and for this result, you can see the highest stress happen at the connection between the middle tube and the top tube, and the higher force will produce higher minimum, maximum, and average equivalent stress. So this is when we apply a 300 Newton force. To improve this design, I will suggest a better connection between the top tube and the middle tube. Either we can weld it, and for the total deformation, we can add another vertical bar between bottom tube and the top tube. That's all for me. Thank you.
Okay, for my part, I've changed the varied force onto the pedal crank with different magnitude of 100, 200, 300, 400 and 500 Newton at the pedal crank position B. So the bicycle frame being analyzed with the bounding condition of fixed support at the front part and displacement for x-axis at the back part. So I'm using NC's workbench and APDL to determine the distribution of total deformation, total bending moment, maximum and minimum combined stress, and the shear moment diagram. So this part is the total deformation. As we can see in the figure, the red color indicates the location of maximum displacement happen on the bicycle frame structure, while the blue color is the minimum values. So the result show this is the result in table T for the varied force 100, 200, 300, 400 and 500. So in the table, the result shows the maximum deformation on this frame is on the middle part of the bicycle, which connecting the seat post and the pedal crank with small total deformation of 0.0537 mm. Moving into the maximum and minimum combined stress. So this is the figure where the upper part is maximum combined stress distribution on static structure with force of 100 Newton. And the second part is minimum combined stress distribution with also force of 100 Newton. So based on the two figure above, shows the maximum and minimum stress distribution when various load is applied at the pedal crank. So this is the table of result, shows the maximum and minimum combined stress for all of the 5 forces in Pascal. So as we can see, as the force increase, the maximum combined stress also increase. So next is the total bending moment. So this figure shows the total bending moment distribution when various load is applied. So the red color indicates the location of maximum bending happen on the bicycles. As you can see in the figure, only a little part of red location. So the highest bending moment occurs with the combination of the head tube and the bottom body part of the bicycle. So this may caused by the gap or the joining section, which is crucial when forces is applied. The table 6 shows the minimum and maximum bending moment result that form on the bicycle. So for the last part is shear moment diagram. So the shear and moment diagram were constructed to perform structural design by determining the value of shear and bending force at specific element of the structure. As you can see, there are 3 shear moment diagrams. So I choose 3 part, which is at the main lower body part, the back lower body part, and also the back upper body part. So 3 of the graph shows 3 different results.
And then we decided to analyze what happened if we vary the diameter of the bottom tube. So this is the boundary conditions that we applied, same like before. There are 1 fixed support at front and 2 roller support at back. So the first analysis, we go to the total deformation. So as you can see, when we increase the diameter, the deformation also decrease. From the illustration, we can see that the total deformation occur highest at the seat tube where the 2 forces applied. So this means that the place where the forces applied, they will have the higher deformation compared to the support. And then we analyze the minimum and maximum combined stress. So as we can see from the table, when we increase the diameter of the frame or the bottom tube, the minimum combined stress will decrease, same like the maximum combined stress. When we increase the diameter, the maximum combined stress will also decrease. So from the illustration, the minimum combined stress occur maximum or largest at the center of the bottom tube at front and the end of the lower back tube. So for the bending moment analysis, we can see that the maximum bending moment occur at the maximum diameter of the tube. So here is the illustration of at the highest diameter tube. You can see the highest bending moment occur at the intersection between the head tube and the bottom tube. And then we're only focusing on 3 parts to do the bending moment diagram. So the first one is the bottom tube. So you can see here is the bending moment diagram. It is maximum at the start and decrease and increase again. And then for the second element is the upper back element. The maximum bending moment occur at the end of the tube. For the third part is the lower back element. and the maximum occur at the starting of the tube and end with the lower bending moment.
Assalamualaikum, my name is Welcome to Johan, and I will present about the applying various forces at the front position at the heat tube. And for this case, I will use total deformation, maximum and minimum bending stress, and the shear moment diagram to run the deep analysis on this heat tube. First, we discuss about the total deformation. For the total deformation, I apply 5 different forces at the heat tube in X direction, and this is the result of the total deformation for each force. And this figure shows the total deformation at 700 Newton, and in this figure we can know the maximum total deformation at frame bicycle. In this figure, it shows that at the top tube is the maximum and at the down tube is the minimum. Next, we move on to the maximum and minimum bending stress. So table 12 and table 13 is the maximum and minimum bending stress for each force, and this is the figure of the maximum and minimum. As you can see, at the maximum bending stress, the whole structure of the frame is in blue color, and for the minimum, the whole structure is in red color. And also, for the bending moment, we focus on the full frame as shown in the figure 30. But for the bending moment diagram, we focus on each part of the bicycle. In this case, I focus on the head tube, down tube, and top tube. And this figure shows the path of the bending moment at the head tube, this one at the top tube, and this one is at the down tube. And this is the bending moment diagram or shear moment diagram of the head tube, top tube, and the lower tube.
Hello, my name is Edmund Vukayong and I'll be presenting on my part, which is the control force. In this part, the structure is analyzed just as it is in the problem. This is just so that the other analysis can be compared to the control analysis. As you can see, this is just as the problem given. Since there is no diameter specified in the problem, we assume that in this analysis, the tube diameter is 20 mm for the center tube, 16 mm for the front frame, and 10 mm for the back support. In the discussion and findings, after comparing the result, we found out that the concentration of stress position does not change. The only difference is the magnitude of the stress. This can be seen in the appendix, where the color of the frame and the position stay the same when we vary one factor. Using the first analysis as comparison, we note that the maximum total deformation has doubled its magnitude from 0.17 mm to 0.34 mm when we increase the seating force from 300 Newton to 700 Newton. This shows that the deformation is in the elastic region of the material because the deformation increased linearly. Using the second analysis as comparison, which is varying the force at the pedal, we note that the total deformation is less than the total deformation when varying the force on the seat post. This is because although the total force acting on the vertical axis is the same with 800 Newton, the distribution force is much more evenly. This is because for the second analysis, there are 300 Newton at the top and 500 Newton at the bottom compared to the first analysis, which has 700 Newton on the top and 100 Newton on the bottom. Thus, the second analysis have much less deformation. Using the third analysis, we note that the value difference in varying the bottom tube diameter is insignificant, since it only can increase the strength of the frame by a little amount. This shows that the thickness is much more important than the diameter. However, the bigger the diameter, a bigger diameter tube makes the joint between each beam stronger because of the large surface area. And fourthly, after applying force on the front of the frame facing the forward and backwards direction, we note that deformation is smaller than all the other analyses. This is because the compression strength of the material is stronger than the tensile strength. When the frame is applied a forward force, all the material is compressed. Thus, it is doing a better job at resisting the deformation since it is a compressive force.
Now we move on to the conclusion part. And so for the conclusion, we have achieved the objective of the project, and we also use the finite element analysis in our project to see the effect of forces and effect of the diameter to the bicycle frame. And NC's FPDS software is very great tool to investigate the deformation, stress, and bending moment of the frame. So in conclusion of our project, we use the different process on the different part of the bicycle frame, and from that we analyze the total deformation, stress and bending moment after we apply the forces on the frame. And for the overall conclusion, we conclude that even though we use the same dimension and material, which is 6061 TC aluminium, we got the different result. This means it is so important to look into detail every aspect of structure, so that the result we got is reliable and accurate before proceeded with the production of bicycle frame. This is because this can prevent failure in the future and save value for our activity. And every part of the frame is very crucial because it affected other part of the frame also. So we need to make sure that every part of the frame is strong enough and safe to use without having any failure which will cause accident to the user. I think that's all from me. Thank you.